Good evening, Ajay sir.
Good evening, ma'am. Good evening, Chanchala ma'am.
Good evening, sir.
Can we start, sir?
Good evening,
Yes,
ma'am.
ma'am, please.
Good evening, ma'am.
Good evening, everyone.
Good evening, everyone. I'm Neha Jain, the session coordinator, warmly welcoming you all to the 5-day training session on statistical analysis with Excel. It is indeed an honor to introduce Dr. Chanchala Jain ma'am, our proficient master trainer and esteemed research expert. She holds not just the title of an expert, but embodies excellence in every sense. Today, on the second day of this training, ma'am will navigate through the captivating topics of chi-square and t-test. This impactful training initiative is brought to you by the Research Foundation of India and the All India Shri Shivaji Memorial Society Institute of Information Technology, Pune, in collaboration with Parul University and Eklavya University. So, as we move forward, let's extend a warm and appreciative welcome to Dr. Chanchala Jain ma'am, who not only possesses a wealth of knowledge but graciously shares it with all of us. Over to you, ma'am.
Thank you so much, Neha ma'am.
Welcome, ma'am.
Good evening, everyone.
Good evening, ma'am.
Happy Sunday to all. Today, we are going to discuss the two tests, that is the chi-square test. Neha ma'am already told we are going to discuss the chi-square test, which we have not covered yesterday. And apart from that, we will discuss the t-test, right? So, as our convention, firstly, I'll share my screen and I'll discuss the conceptual aspect of chi-square test, and then we'll moving ahead with the Excel. And both the Excel sheets, I think, are available on your WhatsApp group. You people can access. So I think I have shared my screen. Anyone can confirm me whether it is visible or not.
Yes, ma'am.
Yes, ma'am. Visible, ma'am.
Yeah, thank you so much, ma'am. So, dear participants, dear friends, we have seen yesterday the descriptive statistics. In that, I tried to explain you what is statistics, what is descriptive statistics, and what are the methods which we can use to summarize the data under descriptive statistics. So we discussed measures of central tendency, we discussed measures of dispersion, and measures of distribution. So this is the very first procedure or very first step to understand our data. After understanding the data, we can move ahead with the inferential statistics, right? So here we will talk about firstly the inferential statistics, and then I'll take chi-square test. So descriptive statistics will help us to describe the data, to summarize the data. But inferential statistics will help us to assess the parameters of population on the basis of sample or sample statistics, right? So if we are having sample, because many a time it happens, we cannot enumerate or we cannot access each and every member or object of the population. In that case, what we do, we are trying to take a sample from the population, and with the help of population, with the help of sample, we are trying to infer the population parameters. So that is known as inferential statistics, right? When we talk about inferential statistics, that means we are talking about hypothesis testing. Hypothesis testing means hypothesis is generally a type of statement. It's a kind of tentative conclusion which we need to test. And for testing that hypothesis, we collect the data and then we can select the two tests, that is the non-parametric tests or the parametric tests, right? So when I say non-parametric tests, so non-parametric tests are not bothering about the normal distribution of data. So we can say these are distribution free tests, right? Apart from that, these tests do not consider the parameters of population. So this way it is known as non-parametric tests. So today we are going to discuss parametric as well and non-parametric as well. So chi-square is a test which generally comes under the non-parametric test category. So we can keep here chi-square test. So chi-square test is a type of non-parametric test. So that means when we are talking about chi-square test, we do not need to check the normality of the data. We do not need to be bothered about the parameters of population. Now, what do you mean by parameters? Parameters are generally known as mean, standard deviation, proportion. These are generally known as the parameters of population. And those who are knowing about the chi-square test, they know this thing that chi-square test formula is based on frequencies. So here we are not talking about mean, standard deviation, etc. We are only talking about the frequencies. Frequencies means count. So now I talk about the chi-square test. So chi-square test is generally a test which is considered or which considers the categorical variable. Categorical variable, can anyone tell me which categorical variables we have seen yesterday?
Height and weight.
Okay. And in terms of measurement scale?
Nominal.
Very correct. Nominal and ordinal. Very correct. So if we are having a variable on either nominal scale or on ordinal scale, we can call it as a categorical variable. And for chi-square test, we need to have categorical variables, right? Now, talking about the types of chi-square tests. So we can say that there are two types of chi-square test. The first one is the goodness of fit, and second one is independence of attributes, or I think it is suffice to say. So these are the two types of chi-square test: goodness of fit and independence of attributes, right? So once if I say goodness of fit, so goodness of fit, for goodness of fit type of chi-square test, we need to have only one categorical variable. And here we should have two categorical variables. So firstly, I'll talk about the goodness of fit, and then we will see independence of attributes. So goodness of fit is only considering one categorical variable. Say for example, if I'll ask the members who are available in this particular meeting that what is your favorite color, right? So might be possible some will say blue. Okay, blue. Then anyone else?
Green.
Green.
Good.
White.
Pink. Red.
Pink.
Red.
I think it is sufficient. It is sufficient because we need to find an example. Otherwise, we need to write the favorite colors of everyone. So I have taken few categories, only 6 categories I have taken, suppose. So might be possible in this meeting, there are people available who are liking black color. So might be possible there are 10 people who are liking black color. Maybe there are 8 people who are liking red color. Maybe there are 13 people who are liking green color. Likewise, 16, 12, 7, something like that, right? So these are the counts. That means I have counted how many of you are liking black color, blue color, red color, pink color, etc. So this is the count of these are the frequencies given to us, right? And here you can see we are having only single variable that is color, and we are having the categories of color, right? So I hope you can understand this. We are having single variable, categorical variable, that is color, and we can categorize color into these categories, and these are the respective counts, suppose, right? This is an example only. Is it clear?
Yes, ma'am.
Yes. Further, if I talk about chi-square goodness of fit. So what chi-square goodness of fit does? It generally try to find the uniformity of the frequencies. Means these are the frequencies, but you can see according to various color category, these frequencies are not same throughout the categories. But in chi-square goodness of fit, we try to see whether these observed frequencies are similar to the expected frequencies or not. So that means we want to check the uniformity of the frequency. That way it is known as chi-square goodness of fit. So means we are expecting this frequency or this count should be throughout same in all categories. This is the logic behind chi-square goodness of fit. Is it clear? Any doubt?
No, ma'am.
Okay, good. So I think I have explained you the meaning of chi-square goodness of fit. Generally, if I talk about the hypothesis yesterday, or I think I just said chi-square is what? Sorry, hypotheses are what? Hypotheses are generally the tentative conclusion, right? So suppose I have written here, there is no there is no significant difference in the observed and expected frequencies, right? So this would be my tentative conclusion. I am saying that there is no significant difference in observed and expected frequencies. But whether this conclusion or this particular assumption is correct or not, so for the purpose, we can collect the data and we can test this hypothesis. If your data will support your hypothesis, you will go with the hypothesis. If data will not support, you will reject that hypothesis. Is it clear?
Yes,
Yes.
ma'am.
Further,
Yes, ma'am.
yeah, thank you everyone. Further, talking about the next, that is independence of attributes, that is IOA. As I said, when I talk about the independence of attributes, so independence of attributes is considering the two categorical variables, right? So one categorical variable, maybe you people have heard about the term contingency table. Yes or no? Anyone has heard? Contingency
No,
table?
ma'am. Explain it because we are not from commerce background.
Okay. So contingency table means it is generally a two-way table where we are taking one variable in row and one variable in column. Suppose I want to see that the habits are independent of gender or not, right? Or I want to see whether the liking of reading newspaper is independent of gender or not. So might be possible I am having two variables, that is gender. In that I am having two categories, male and female, and liking for reading the newspaper, I am having two categories, yes or no. Now how many of the males are liking to read the newspaper? So we can write the count here. Similarly, how many males who are not liking to read the newspaper, we can write the count here. Similarly, in case of female also, yes and no count we can calculate, and that way we can write here the total of rows, and this would be the total of columns, right? So this is known as contingency table. Generally it is a two-way table, one variable with the categories in the row and one variable with the categories in the column. So this is known as 2 by 2 table. Is it clear?
Yes, yes.
So it is, I am writing the name of the table, or this table is generally known as contingency table. Done? Moving ahead. Now if I want, sorry.
Ma'am, does contingency table means 2 cross 2 or 3 cross 3?
No, it can be any number, ma'am. There is no fix. It can be 2 by 2, it can be 2 by 3, 3 by 2, 3 by 3,
Okay,
depending upon how many categories we are having in one categorical variable.
okay, thank you, ma'am.
Okay. Now talking about how we can formulate the hypothesis of independence of attributes. So here we need to generally write there is no association between categorical variable 1 and categorical variable 2. Or other way around, I can write the hypothesis. Categorical variable 1 is independent of categorical variable 2. So this way we can formulate the hypothesis of chi-square independence of attributes. I hope these things are clear.
Ma'am, with the help of this chi-square test, we can check the association of attribute exactly.
Yes, attributes means the qualitative terms to
Yes,
because
yes,
we're
yes.
talking about categorical variables.
Yes, yes, yes.
Okay.
Ma'am, can you share the screen, please?
I think screen is already shared.
I can't see that.
Okay. I hope for the remaining participants it is visible.
Yes, ma'am.
Yes, it's visible.
Yes.
Ma'am, it is visible.
Yes, ma'am.
Sorry, let me see what's wrong.
Ma'am, it is visible.
Satish sir, you need to pin my screen. Satish sir, pin my
Okay,
screen.
I will do that. Thank you.
Yes. Okay, moving ahead. Now I think I have shared a sheet with all of you. So I expect you to open the sheet which I have given to you. I think I forgot to open. Give me a second. I think this is a sheet which I have already shared with all of you, right?
Yes, ma'am.
Yes. So firstly, I will talk about how to perform chi-square goodness of fit in Excel. So friends, I hope you people have opened your sheet. Now I'll talk about this particular thing. So I'll expect everyone to remove this values of expected frequency column, because here we need to calculate that. We are having only, when we talk about this chi-square test, we will have only the.
Excuse me, madam. Where have you shared it? I didn't get it. This sheet, where have you shared, ma'am?
I think it is available on WhatsApp group.
WhatsApp group. Okay,
On
just
WhatsApp
I
group.
have joined. I was trying from yesterday, but just I am able to join at WhatsApp group. That's why I didn't get it. I mean, few minutes ago, I have joined after.
Okay, Geeta ma'am, so I request any of the participants if they can share the same sheet which I have shared yesterday and today in the group. Can anyone do the favor?
Good evening, ma'am. Ma'am,
Yes,
कल
sure,
की और
I'll
आज
share.
की हमें मैम
Madan sir, do you want to say something to
जी
me?
जी
Yes, sir.
मैम कल की और आज की शीट भी हमें नहीं मिली है मैम, पिछले कल की रात को
Madan sir, I think these are the technical things you need to know. There is a WhatsApp group. On WhatsApp group, everything is available. I hope you are there on WhatsApp group, right?
मैम
Are
जो
you-
मेरे
Just
पास
now,
WhatsApp group
just now I have shared on WhatsApp group. Please check it.
Thank you, Nidhi ma'am.
Yeah, sure. Please, welcome. ma'am.
Madan sir, I think you are on WhatsApp group, right?
जो मेरे पास नंबर है उसमें शायद मैं WhatsApp ग्रुप में नहीं हूँ शायद, इसलिए मेरे पास नहीं है.
Okay.
In emails, they have given WhatsApp a link. You click it, you try it, you can join it.
चेक करता हूँ.
I have got now. Thank you.
Okay. So shall I proceed?
Yes, ma'am.
Yes, ma'am, please.
Yes, ma'am.
Yes, ma'am. Yes, madam.
Please, ma'am.
Thank you. So I think yes, I was here. So I was telling this thing to everyone that please remove the values available in the expected frequency column, because we need to calculate those figures. So how you need to calculate that? Firstly, I'll tell you that, right? Firstly, we will read the question. The question is, the table shows the number of people's absent on a particular days in a week. Suppose being a teacher, we want to see that the frequency count of the absentees is throughout same for a particular week or not. So in that case, we can see here, we have taken the days from Monday to Friday. Number of absentees for Monday, Tuesday, Wednesday till Friday are given in the next column. So whenever these count of frequencies are given, these are treated as a observed frequency. Is it clear? Right? May I move ahead?
Yes, ma'am.
Now, when,
Yes, ma'am.
yeah, I think I need to write here the formula for you people. Can anyone tell me, do you know the formula of chi-square or not?
No, ma'am.
Okay.
Yes,
So
ma'am.
No, we don't know.
Summation of F4 minus Fe whole square divided by F4
sorry.
minus Fe. Summation of F4 minus Fe whole square divided by F4 minus Fe.
Very good. This is the formula. We can say O minus E. One in the same thing. F4 means frequency, observed frequency. Fe means expected frequency. Or O and E also stands for the same thing. One in the same thing, right? Divided by E. So difference or the square of the difference of observed and expected divided by expected, and the sum of this is generally gives us the chi-square value, right? But here when we talk about Excel, so how means in the formula you can see we need to have two things, observed frequency and expected. So whatever frequencies are given, they were treated as a observed frequency. We need to calculate the expected count, right? So in case of goodness of fit, the expected count figure will be nothing but the average of this observed frequency. So you can see here I have selected my column of the number. You can see, maybe you would be, just a minute, I need to show this. Yeah, maybe you are knowing this thing. Once we are selecting a particular column, in this bar we can see the average count and the sum. Where I'm rotating my mouse, you can see here the average is showing as a 100 to us, right? Average is coming as 100. Or other way around, what I can do, I can come here and I use the function known as average, and I can give the range of observed frequencies, and I can close the bracket and press enter. This way we can get the expected count, right? And the same formula you can copy down in the next cells also, because expected count will be same throughout all the categories. So this way we have calculated expected frequency. I hope everyone has got this. May I proceed? Any confirmation?
Madam, please repeat again that expected frequency formula.
Ma'am, it is nothing but it is the average function you need to use. You can use here like
Yeah,
this.
I got that. Yeah.
Yes, and then you need to give the range.
Okay.
So we can enter average is coming as 100, or either you can use the same formula in the remaining cells, or you can count here and you can enter manually also 100, 100, 100 throughout the all 5 days, right?
Okay, thank you.
Fine. May I move ahead?
Yes, ma'am.
Yes, ma'am.
After calculating the expected frequency, usually when we talk about the Excel, in Excel there is no such way to directly get the value of chi-square. There is a function called chi-square.test. So you need to do, you can see I have given you 3 functions here, right? So firstly, I'll talk about the very simple function. You need to put here the equal sign. I think we all know that whatever functions we want to execute in Excel, for executing them, we need to put a equal sign firstly, right? So I'm putting here a equal sign. Now I'm typing CHI. So once I am typing CHI, you can see all the functions which are starting from CHI. You can see all of them in a list, right? So you need to select here CHISQ.test, right? Maybe according to the versions, this can be different also. It can be CHIQSQ without, means there should be no period. That is, no point will be there, might be possible. So according to the versions, this function can be different also, right? If not, if you are able to find the same function, you can select that function. And now you can see it is asking us 2 ranges, actual range and expected range. Actual range meaning is observed frequency, expected range means expected frequency range, right? So I have selected here the first range, that is the observed frequencies, putting a comma and giving the next range for the expected frequencies. And then I can close the bracket. I hope everyone has done this.
Yes, ma'am.
May I proceed?
Yes, ma'am.
Yeah, good. Now What you need to do, you need to press only enter and you would be able to get a value. This value is known as the p-value, means CHISQ.test function is giving you the p-value. P-value is what? I think those who are doing research or researches, or maybe those who are writing research papers, those who have completed their thesis, these people are knowing p-value. P-value is nothing but this is a significant value, because now you can see in our hypothesis also we have written, when I have shown you the hypothesis in the word form, we have written there is
No significant
there is no significant difference in the observed and expected frequencies. Means possibilities there, difference may be exist, but that difference is significant or not, that we are testing here, right? So we can say this thing here, the according to the p-value, that we can convey or we can conclude that thing, that whether the difference in the observed and expected frequencies is significant or not, right? So generally, when we talk about this p-value, can anyone tell me level of significance is known to everyone or not?
0.05.
Okay.
5%.
Usually, we take level of significance as 5%, and we compare the
What is this exactly, ma'am?
level of significance is, ma'am, this is maybe if you have studied about the hypothesis, you are knowing this thing. This is a this is a chance of percent of committing type 1 error. Means when your hypothesis is true, still you are or your data is rejecting it. So chances of that is 5%. Chances of committing type 1 error is 5%. That is level of significance, right? So means how much chance of conclusion, means how much chances of error is there in your conclusion, that is the level of significance. So now we can compare the p-value with the level of significance. So as per the thumb rule, or as per the assumption, or as per the procedure, we need to always compare p-value with the level of significance. So if you are knowing the thumb rule, I am writing here, the thumb rule says if p is less than your level of significance, in that case we are going to reject the null hypothesis. But if p is greater than level of significance, we do not reject the null hypothesis, right? So these are the thumb rules. Whatever test we are applying, these rules will not change. Now we can compare our p-value. So here we can see that in our case, the p-value is less than 0.05, right? 0.027 is less than 0.05. So that means we are going to reject the null hypothesis, right? And in this case, what we can say, that there is a significant difference in the observed frequencies and expected frequencies for absenteeism, right? Clear? I hope it is clear.
Okay, madam, one doubt. If we are going to reject the hypothesis, then we have to give the statement as there is a significance between the.
Well, obviously, ma'am, if you are rejecting whatever you have formulated, so you need to have something to say, and that is known as your alternative hypothesis. So you can say if there is no significant difference, so that means alternatively we are saying there is a significant difference.
Okay, madam. Thank you.
Yeah, fine, ma'am. Any other question?
Namaste.
Yes.
Is it possible to calculate chi-square for the Likert scale frequency?
If you are taking your data in terms of frequency, it is quite possible, sir. No problem. If you are not taking mean of that, so in that case, you can calculate. Say, for example, as you say, Likert scale, so suppose I have a scale of strongly agree, disagree, neutral, disagree, and strongly disagree. So if you are calculating how many of the people are strongly agree with the statement, so suppose you have written 17, then suppose it is 28, then suppose it is 45, then 30, then suppose 24, likewise. So in that case, if you are taking the count, so in that case you can apply, no problem with that. Fine, sir?
Thank you.
Yeah. So I hope the first thing is clear to everyone.
Yes, ma'am.
Now there are two more functions I have given to you to get the critical value and the calculation.
Ma'am, I have a question, Chanchal ma'am.
Yes.
Imran.
Yes,
Ma'am,
sir.
we have formulated the hypothesis. There is no difference. If we have written alternative form and the value will be rejected, so in that way, how we will interpret it? Means if we would have written there is difference, so the calculated value will remain same.
Sir,
So how,
always the null hypothesis we are writing in the no form, right? So suppose you have written, suppose I am writing here the null hypothesis firstly for you. Suppose I have written here, there is no significant difference in the observed and expected frequencies for absenteeism. Right? Suppose this is the hypothesis I have written, right? Now, if suppose I am copying the same and I have converted this into the alternate form, right? So might be possible you have only formulated your alternative hypothesis. That is generally in the a significant difference form, right? So your conclusion will not change, sir. It will always remain same. It is not necessary, but usually as a, because all whatever test we are applying to test the null hypothesis always. There is no test we are applying for the alternative hypothesis. Always we need to check the null hypothesis. So that is why we need to formulate as a tradition, we need to always formulate the null hypothesis. But many a times when we are reading the research papers, might be possible to change the things. Generally people are giving the alternative hypothesis also, and they are not mentioning the null hypothesis, but still the results will not change. They will always be, means always the testing procedure will remain same. Is it clear?
yes, ma'am. So in that case, if we have taken alternative hypothesis, so we will simply write that there is a association in between two variable.
Yes, yes.
We do not to explain that there is no difference. Because we assume that alternative is accepted.
Yes, because if your p-value is less than your level of significance, so that means your data is not supporting your null hypothesis. So you need to conclude your alternative hypothesis. And if you're writing only your alternative hypothesis, so you will conclude that.
Yes. Thank you.
Okay, fine, sir. So may I move ahead?
I have a question.
Yes.
Just like you said, if p-value is less than level of significance, then we will reject the hypothesis. And if it is greater than level of significance, we will accept the hypothesis. Then what if p-value is equal to level of significance?
Ma'am, it is totally your assumption at what level of percentage you want to test your hypothesis. It will be totally your risk, your conclusions, your decisions. You will be answerable for everything. Usually in research, 5%, 10%, 1% are generally prescribed, but it is not necessary. If you want to test your hypothesis at 99 or 97.5%, you are free to do so also. But these are more relevant or more what I can say used level of significance, that is 5%, 10%, and 1%. But it is totally up to a researcher.
Okay.
And whatever level of significance you will take, you need to always compare your p-value with that.
Okay.
Okay. Any other doubt?
No, ma'am.
Fine. So I think we have discussed about the chi-square goodness of fit. Now we are talking about the next thing, that is the independence of attributes. So I expect everyone to open the third sheet with the name demo IOA. Open.
Yes, ma'am.
Fine. Thank you. So here we can see we are having the wealth and we are having the graduation level, whether the person is graduate or not, and what is the level of wealthiness, whether the person is wealthy, he's in terms of wealth, he is middle wealthy people, or he is a poor kind of person. So here, firstly, we are writing our hypothesis. So I am writing my hypothesis downward. Here I am writing, there is no association between level of wealthiness and status of graduation. Then this would be our null hypothesis. Other way around, I can say this thing. Just a minute. Other way around, I can say this thing. That is level of wealthiness is independent of status of graduation. Is it okay? Is it fine?
Yes, ma'am.
Right. Now, talking about, it is very clear that we are having the two variables or two categorical variables. One is the level of wealthiness and second is the status of graduation. So in a status of graduation, we can see we are having two categories, yes and no. In the status of wealthiness, we are having the three categories: wealthy, middle wealthy people, and the poor people, right? So this particular table is a very simple table. So here you need to firstly create a contingency table. So I have written here the contingency table. Now how you can calculate that or how you can create that. So for that, suppose middle and third level is suppose poor, and here I am writing the status yes and no. Is it okay?
Yes,
Yes,
ma'am.
ma'am.
This would be your graduation level, right? Now we need to create a table like this. So I am taking a border so that it would be clearly visible to all of us, right? Now how we can do the calculations? So we all know, I think I have already given you a filter. If not, you can use come here at the home tab, and from home tab we can use the filter. Now we will do the filter of this particular table to calculate these values. So person who are wealthy and who are graduated, right? So what you need to do, you need to come here and you need to select the status of wealthiness, and then you can come and select here yes, and you can press OK. Now you can see count is coming as 6, right? You can see count is written here 6. So I have written here 6. Now similarly, in place of yes, I am selecting no. Now you can see no is 5. Wealthy people, no graduation is 5. Right? So I am coming here and I'm writing here 5. So you can see how I am doing. You can only note down the figures so that it will save our time, right? Now similarly, selecting the next label, that is middle, pressing OK, coming here and selecting the yes. So how many of people who are middle in terms of wealthiness? So the total count for yes, these are graduated also. So the count is coming as 9. Now for yes it is 9, and for no it is 7, right? So now so I think firstly I need to select all and I need to write the figures. So I am writing here 9 and these are the 7, right? Fine. Again coming here and doing or selecting the poor only, pressing OK, coming here, deselecting all, selecting yes. So how many of the people who are poor and those who are graduated? So 5. And then again for no. Pressing OK. So now count is 6. So 5 and 6. And now I'm removing these. So I'm writing here 5 and 6. Done? Done, everyone? Okay.
Yes, ma'am.
Yes, ma'am. No, no, please repeat.
I think my filter, filter is very easy. Everyone can do by his or her own. You need to only see what I did. You need to come here on the filter. You need to deselect this. Once you need to select first category from wealthy. Similarly, come here in the graduate and select one category from the graduate. That is yes. This will be the combination of wealthy and yes. Count you can calculate and you can write here. And that way you can make all the combinations and you can count the figures and write in the contingency. Is it fine? So you don't need to do anything. Whatever count I have written, the same you can write there. Right? Is it okay? May I proceed?
Yes, ma'am. Yes.
Yes.
We will save our time. And then I have written here the sum. Okay. Now you can see I have selected my column and you can see count is coming as 38. Now we can see the count of this or the sum of this count is also 38. So the total sum is 38. Done?
Yes, ma'am.
Yes, ma'am.
Now we are proceeding with the next thing. You can see if you have made your contingency table, the same table you can copy like this without selecting the total I have done, because this way you will not do any mistake. And then you need to do the total
Please
weight.
mute yourself. Your disturbance is coming. Preeti Sharma, ma'am.
Okay, again I'm repeating. This is the contingency table. You can write here. This is for the observed frequency. Right? This is for the observed frequency. Now I am making the next contingency table for the expected frequency. I am waiting. Please make this. If you are done, please tell me so that I can proceed further to tell you how to calculate expected frequency. May I proceed?
Yes,
ma'am.
Yeah. So now, sorry. I'm not getting.
Yes, ma'am. Can proceed.
Yes, yes. Thank you so much, ma'am. So now you can see what we need to do here. Now I have copied down this particular area of the table, this, and I have do the these cells vacant. Right now, what I need to do, I need to calculate the expected count for each and every category in the GOF. Also, we have seen for all the categories we need to calculate the expected count. So same way for all the categories of this particular contingency table, we need to calculate the expected count. Right now, please pay attention very carefully what I am doing here. Until or unless I do not give you time to perform, please do not do so. Please see here what I am doing, right? I have written here a formula. You can see E is equals RT into CT divided by GT. This means row total into column total divided by grand total. Now, what is row total, column total, and grand total? So you can see here, if I need to calculate expected count for this particular cell, right? Means this one, 6. So respective to 6, the row total will be 11. Respective to 6, column total will be 20. And grand total will always be 38. Is it clear? Similarly, for suppose 7, I will calculate the expected count. So the row total will be 16, column total will be 18, and the grand total will be 38. I hope it is clear to all. May I proceed now how to perform?
Yes, ma'am.
Yes, ma'am. Please repeat again.
From where, ma'am?
Ma'am, one time repeat, please.
From where, Khushbu ma'am?
It's formula. It's formula.
Formula is row total into column total divided by grand total, right? So if I want to calculate the expected frequency for 6 means this 6, you can see wealthy and yes. For wealthy and S, count is 6, right? So for this 6 observed frequency, I want to calculate the expected count, right? So you need to see its respective row total, which is 11. Its respective column total, it is 20. And this is the grand total. For 5, row total is 11, column total is 20, and grand total is 30. Is it clear?
Yes, ma'am. I got it.
Now coming here and applying this, you can see firstly I'm putting here the equal sign, right? Now for 6, row total will be 11, right? Multiplied by column total will be 20, right? Here I'm using the function F4 or only F4 key so that I can drag the formula. So I expect everyone should do this. Please do the same if you are performing along with me, right? Firstly, I have selected, you can see the colors also. Colors are indicating you which cell I have selected here. I have selected H5, that means this particular cell I have selected. Maybe our cell references will be different because I am performing on my sheet and I have selected my own space. I don't know where you people are performing. So according to your performance, the cell reference will be different. So please do not copy my cell values or cell references. Do according to yours. Fine.
Yes, ma'am.
Now divided by, this is the grand total. Again, you need to use F4 or function F4 depending upon your laptop. Maybe it is this particular dollar sign can come by F4 only, or maybe using function plus F4. So it is totally up to your your keyboard functioning. I don't know what is the way or which type of keyboard you are having. So please check whether F4 is doing this particular operation or function plus F4 is doing this operation. And this is all. You need to only press enter to get the expected count. So may I press enter?
Yes, ma'am. Yes, ma'am.
Done. I have calculated the expected frequency. Now I'm dragging the formula. Once I'll drag the formula, I'll get the expected count. Now you can see. Similarly, coming for the no category, putting here a equal. So in no category, 5 is there. So for 5, total count, row total is 11 multiplied by column total is 18. I'm using function F4 divided by grand total, again function F4. Pressing enter. This function F4 why I'm using, so that I can drag the formula. If you want to perform, if you are unable to do so, what you can do, every time you can come to the particular cell and you can apply the formula again. So if suppose you are having a 3 by 2, here you can see we are having a 3 by 2 table. So 6 times I need to apply the formula. But using those, what I can say, freezing of the cell, maybe you people are knowing absolute referencing and the relative referencing. So this is known as absolute referencing. That way I have freeze the cell value and I can easily now drag the formula. So only once I have applied the twice I have applied the formula, and that way I have got the 6 times of expected frequency values. Is it okay?
Ma'am, how you are dragging? I just missed.
Ma'am, once you will apply a formula on a cell, you would be able to see at the right corner a small square is coming. You need to put your mouse there and you need to drag the formula.
Okay, madam. Thank you. Thank you.
Okay. So this way we have calculated the expected frequencies. Also now your way is very simple. Again, you need to use equal sign, CHISQ dot test, the same way which we have, the same thing which we have done in the previous question. Same function I'm using here, and I'm giving the range of expected frequency. Please see properly what range I have given. I have given the range of frequencies only. You do not need to include totals. I hope you have seen what I have done. I have selected only yes and no category frequency count. I have not selected this total column or this total row column. Done. After that, comma, and then select your expected frequencies from the next table and close the bracket. Done.
Yes, ma'am, got it.
Okay, so may I press enter?
Yes, ma'am. Yes, ma'am.
Okay, I think someone forgot to
Veena
mute
ma'am.
him.
Veena ma'am.
Yes, ma'am. Yes, ma'am. Sorry for the inconvenience.
So now, no, it's fine, ma'am. Now we got p value, which is 0.84, right? So suppose we are checking this particular hypothesis at 5% level of significance. So we can say that the p is greater than 0.05, right?
Yeah. Okay, ma'am. Okay.
So that way, if p is greater than 0.05, what we will do? We are going to accept the null hypothesis, right? And if we are accepting the null hypothesis, we are concluding this thing that the level of wealthiness is independent of status of graduation. That means there is no linking of wealthiness status in the graduation. A poor person, a wealthier person can be ungraduated also. Is it clear? He is from the non-graduation background as well. So this way, this is the independence of association or independence of attributes. Now, I think I have shown you how to perform the chi-square goodness of fit and independence of attributes. You are having the two sheets for practice purpose. You can perform by your own for doing the practice. Now I'm moving for the next, that is t-test. So shall I?
When we will perform goodness of fit and independence of association, so how we will decide which one we have to perform?
Sir, it is very simple. One variable goodness of fit, two variable independence of attributes.
Okay, one variable goodness of fit, two variable independent of association.
Obviously, association is possible only when we are having two variables. Say,
Yes.
for single variable, how we can perform association?
Right. Ma'am, if in this case, if we have taken 10%, then our null hypothesis would have been rejected rather than at 5%. If we would have taken 10% level of
Even
significance.
then, it will not be rejected, sir. You can say p value is coming as 0.84, that is 84%.
Yes.
And the level of significance is 10%. So in that case also, you will say the same thing. Right?
Okay.
Okay. So shall I move ahead?
Yes, ma'am.
Yes.
ma'am.
Yes, ma'am.
Okay, so I expect everyone to open a next sheet I have given to you with the name demo t-test. But I think before talking about the t-test, firstly, I'll go to this Word file. I'll talk about the parametric test and then we'll come back to the t-test. So parametric test means the test in which we need to check the normality, which we have seen yesterday, how to check it using skewness and kurtosis. So the same way you can check the what I can say normality of your variable firstly, right? So parametric tests are those tests which are bothering about the normal distribution of the data, and also these type of tests are based on the generally the numeric variables. It is not like only numerical and categorical can both be there, but one numeric variable should be there when we talk about parametric tests. And if assumptions of parametric tests are not meeting, in that case, we should go for the non-parametric test. So there are various type of non-parametric tests, various type of parametric tests are available, like t-test is one of them. Then we are having ANOVA. Then generally correlation regression also we can keep under the parametric test category. So this
ANOVA ANOVA test is known as also F test.
ANOVA, we are through F we are representing the value of ANOVA.
Okay.
Okay, so now further if I talk about the t-test, so in case of t-test, there is a variety available. Generally one sample t-test maybe you have heard about, and two samples t-test, right? So one sample t-test and two, under the two sample t-test also there are two types of t-test: independent samples t-test and dependent samples t-test, or paired samples t-test. So this is the variety available. Again, when I talk about one sample t-test, one sample t-test means we are comparing the sample mean with the population mean. That is the one sample t-test. In two samples t-test, if I talk about independent samples, I'm copying this just a minute to save my time. Yeah. So if I talk about the independent samples t-test, so in case of independent samples t-test, we should have one numeric variable and we should have one categorical variable. And in categorical variable, there should be two categories. Two categories means two labels or groups. This is the requirement of independent samples t-test. We should have one categorical variable and one numeric variable. And in categorical variable, we should have two categories, right? Now talking about dependent samples t-test. So in dependent samples t-test, generally what we do, we are generally, we will have a one sample, but for one sample, we are collecting data twice. Say for example, suppose for before conducting this workshop, suppose I want to know the level of participants in Excel, right? So suppose at the first day, suppose I have taken your quiz or your test on how much you are understanding about Excel or use of Excel in statistics. So I have taken your one test on the first day, right? Then I have taught you for the 5 days, and then again I have repeated the same test for you. So that way I want to compare the level of the knowledge is increased or not after my teaching in the participants. So that way it is a paired sample t-test. So that means whenever we are talking about the paired sample t-test or dependent sample t-test, we should always be having the same number of people in both the conducts. So suppose in this workshop, suppose 100 participants are there. So initially at the first day also the 100 participants will give that particular test, and at the end of that particular this workshop, again 100 participants need to give that particular test, and that way I can compare these scores, and this will become the case of dependent samples or paired samples t-test. The case is clear?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Okay, fine. So now this is the theoretical aspect. So to understand or to enhance your understanding more on this, we are moving to the t-test Excel sheet, and that way we will understand what is t-test exactly and how you can perform. So you need to open a demo sheet of one sample. Sorry. So here you need to open a demo sheet of one sample t-test. Here we can see we are having a height variable listed here for I think around 10 or 11 or 12 people. I need to check for 12 people we are having the height count, right? Now the mu, that is the population mean, is given as 66. Now you can see the formula of t, because when we talk about the one sample t-test in Excel, so there is no function available. So what you need to do, you need to have the, or you need to calculate the t value manually in the Excel. So for the purpose, you need to know the formula. The formula says t is equals to x bar minus mu divided by sigma divided by no, it is not sigma, it is the standard error of mean. So you can say t is equals to x bar minus mu divided by standard error of mean. So standard error of a mean formula, you can see, I think I have given you in a sheet also. That is standard deviation divided by square root of n. N stands for sample size. So this would be the way of calculating t values. One by one, we will calculate everything here. So firstly, I am coming here and I am writing the sample mean. Firstly, we will calculate the sample mean. Then we will calculate the standard deviation. Then we will calculate standard error of mean. Then we will write here the value of mean, and then we will calculate t. Right? So I am coming here and writing firstly the average function I am using here to calculate the sample mean, and I can give the range, and I can close the bracket, and I can press enter. This way I can get the sample mean. Is it fine? Everyone has got this?
Yes, ma'am.
Yes, ma'am.
Okay, fine. Now put a equal sign, right? STDEV.
Madam, excuse me, ma'am.
Yes.
Madam, same sheet I am not getting, means different sheet. There's a sheet like school board, something sheet is there in demo T test. School board wanted to see if reading test scores have changed in the past 30 years. That sheet I got actually in the WhatsApp group. What means like this sheet?
Ma'am, I think you can find there are so many worksheets available. I told you open a demo one sample.
Demo one sample. Okay.
Fine.
Ma'am, can you post again these sheets, because I joined right now. Yesterday I couldn't join because of some reason.
I think you can understand it would be little difficult for me to switch from this screen to other. So I think we can request any participant if the participant can share the sheets.
Okay, fine.
So anyone who can help, ma'am, please share the sheets again in the WhatsApp group. So please give me a nod whether I can move ahead or not.
Yes, ma'am. Given. Please.
Yes, ma'am. Right now we can move ahead. Later on, I will check it once.
Okay, ma'am. Fine. Thank you so much, ma'am. Now talking about the standardization, so we are using STDEV function, and in this you need to pass the range of the data, and you can press enter. So this way we will get the standard deviation. Is it fine?
Yes, ma'am.
Now talking about the next thing. So here you can see standard error of mean. Standard error of mean says, just a minute. So here I am shifting it down to write the value of n. N is what? It was the sample size, which is 12. So total 12 persons height is given to us. So I have written here 12. Now coming here and calculating standard deviation or standard error of mean, which is equals to standard deviation divided by square root function. You need to
Madam,
use.
excuse me, madam. N is 10. N is 10, madam. First two line are the written things means.
Ma'am, I think you can select your this particular column and you can count.
It's 12. It's 12.
Yes, ma'am. Yes, ma'am.
Okay. So now you can see what I did. I have written here the standard deviation. I have selected this divided by square root in brackets 12, or you can select this n also. So up to you. If you want to give the reference, that is also fine. And you can press enter to get the standard error value of standard error of mean, and I can press enter. I hope I can press enter. Everyone has got it.
Yes, ma'am.
Okay. Okay. Now we got the standard error of mean. Now mu is already given. So in this type of question, in case of one sample t-test, we need to know the value of population mean. If it is given, it is good. But if not, in that case, you need to assume by your own what is the mu value or what is the population mean value. So here I have written here the mu value is 66. So it is up to you. Suppose if I am doing this is the height value, or these are the heights in context to the in context to the Indian or India. In context to the India, these heights are given of the male persons. So we can see using the statistical report generally what is the average height in India of males. So that way we can get an idea and we can assume this would be the mu, right? So if for one sample t-test, we need to know the population mean. Now coming to calculate the t value, I am writing here equal sign, As per the formula of t, you can see it is x bar minus mu. So x bar is your sample mean. I selected this, minus mu is this particular value. I have put this particular subtraction in the bracket, divided by standard error of mean, that is this. I hope you got it.
Yes, ma'am.
Now you can press enter. So this is your t calculated t value. After that, you need to calculate the p value. So for p value, why we have calculated this?
Ma'am, once can you show T?
This is the t.
Okay, ma'am. Okay, right.
Okay. Now, for p value, you can see I have given you the formula, but this formula is demanding the calculated value of t. So for the purpose, we have calculated this, right? Now I'm using an equal sign, writing t dot dist dot rt. Right? Here you need to give the calculated t value, comma. Degrees of freedom will be n minus 1, which is 11. And then you can close the bracket. Is it okay? May I press okay? May I press enter?
Yes, ma'am.
Yes.
Second, ma'am, 1 second.
Okay.
Ma'am, please show mu.
Sorry?
Please show mu.
Show mu means mu is already written here, 66. Ma'am. What
How
is the
it-
new? Sorry?
How to get the that
How to calculate mu, that want to.
I think I told this thing, ma'am. Mu will always be given. If not, you need to assume it. Because in one sample t-test, we are comparing the sample mean with the population mean. So I said this thing. Suppose we are assuming this is the males had given to us in context to India. So we can understand in India what is, or we, from a statistical government reports, we can see this thing. What is the average height of males in India? Approximate figure we can take as a population mean.
One more thing, like how this freedom is going to be decided.
Sorry?
The freedom parameter is going to be
Ma'am, it
decided.
is n minus 1.
Okay.
Degrees of freedom formula is n minus 1. Here I am writing df. Degrees of freedom is nothing but it is n minus 1. Everyone has got this. May I move ahead with the interpretation part?
Yes, ma'am.
Yes.
Yes,
Now,
ma'am. Yeah.
you can see our p value is less than 0.05. So that means we are not going to accept the null hypothesis. We can conclude this thing. There is a significant difference in the height, sample height n in the population height. This would be the null hypothesis, which we are, this would be the alternative hypothesis, which we are concluding, that there is a significant difference in the mean sample height and population height. Is it fine?
Yes, ma'am.
So we are rejecting the null hypothesis, right, ma'am?
Yes, sir. That is
Thank
why
you.
I said there is a significant difference.
Right.
Ma'am, one question. Generally, we use t-test for small sampling. So it is always and should be less than or equal to 30.
Just a minute, ma'am. Yes, will you please repeat your question, ma'am?
Generally, t-test we use for small samplings, na? So is it any condition that it should always be less than or equal to 30, or we can use it for 50 or 100 also?
Ma'am, after the central limit theorem, there is no rule like this. Generally, central limit theorem says if we are increasing the sample size from 30, so that way it is tending, your data is tending towards to the normality, right? So for the purpose, if you have applied the statistical tool using the SPSS, you can know this thing that in SPSS there is no test like that test. Only t-test is available. So either it is for the small sample or for the larger sample. For both, we are using t-test there.
Okay, ma'am. Thank you.
Okay, ma'am. So may I move ahead?
Yes,
Ma'am, this T value, that T dot dist dot rt, that formula is not to be shown, ma'am.
It's not coming, ma'am, for me also.
Ma'am, maybe in that case, this is a problem of the version. So in that case, you need to check. Maybe there is some other formula will also be available. You can check inverse or something formula will also be there. Using that, you can check. In that parameter will be same, x and degrees of freedom.
Okay, okay,
So
okay, ma'am.
from the different function also we can achieve. Maybe in older versions, the function was different.
Okay, okay, ma'am. Ma'am, and one more that can you just show the T? Can you just place the cursor on T?
This one.
Yeah, okay. We'll take the sample mean, standard error, and mu.
Ma'am, I
Okay.
think you do not need to read or understand this thing. If formula is available in your sheet, from that
Yeah.
you can move.
Yeah, but I was getting a different answer, so I
Okay, fine.
cross
Now
check.
it is okay?
Yeah, okay, ma'am. Okay, right.
Okay. So if it is done, so we are moving ahead with the next thing, that is the demo or sheet. Means you need to open a third sheet with the name demo independent. And again, I'm repeating, please open demo independent here for the performing the independent sample status. I hope everyone has got this. I think Nidhi ma'am was there. I don't know the name. Neha ma'am or Nidhi ma'am was there who was not finding previously. Ma'am, have you found?
No, madam, still I am searching. Actually, I am not able to get. So I thought if someone provide that, it would be a great help.
Ma'am, already it is shared again. Please check on WhatsApp group, Nidhi ma'am.
Yeah, I'm checking actually. Means whenever I download, now the different sheet is coming.
No, like inside the main file, there are various sheets, so you can check it with the name. For today, the two sheets are shared, the T-square and chi-square twist. So you can check it. I think we have shared.
Yeah, actually, demo. 1 second.
Yes, there are different Excel. There are different Excel sheets in one sheet. Yes, ma'am, got it. Thank you so much.
Okay. So I think I can now perform the demo independent sheet I have opened, and I can perform independent sample status. So firstly, we can see here study hours of female and male students are given in this particular sheet. And we need to check whether there is a difference in the mean study hours of male and female, right? So here we are having two variables. First is study hours. This is our numeric variable. Second variable is gender, that is with the two categories, male and female. So that this is the requirement of independent sample status. Now I am writing here the null hypothesis. There is no significant difference in the mean study hours of male and female students. This is fine.
Yes, ma'am. Yes, ma'am.
Okay, fine. Now you can see when we talk about independent sample status in Excel. So for both the groups, your data should be in this form. But those who are knowing SPSS and they have performed analysis in SPSS, there is a different way of arrangement of the data. In that way, we will having the gender variable in one column and study hours variable in the next column. But when we talk about Excel, the format will be different of the data. In the one column, there would be one category for the numeric variable, and there would be second category of the numeric variable. Is it clear to all? This is the difference in Excel and SPSS. Is it fine?
Yes, ma'am.
Okay. Now, hypothesis we have already written. Now to perform independent sample status, you need to go to the data menu. Then you can click on the data analysis toolpath the way we have done yesterday, right? You need to click on that. You can scroll down your cursor, this scroll bar, and you can find there are three types of t-tests available. First one is pair two samples. Next is two sample assuming equal variance, and two sample assuming unequal variance. But the problem is we are not knowing that variance is same or not in the data. So in that case, you can go up and find one more test is available with the name F test to sample for variances. Is it clear to all? You need to open F test to sample for variances, select this and press OK. May I press OK?
Yes, ma'am.
Okay, fine. Now you can see it is asking us the ranges for both the variables. So you can select your data from your sheet. I have selected my data including the labels. Up to you. Please be cautious and check if you are selecting your data including the labels. In that case only you need to select this checkbox. If you are selecting only observations, please do not select this checkbox, or else our answer will be different, right? Now coming to the output option, so I'm going with the first option and selecting suppose this particular set and pressing OK. May I?
Yes, ma'am.
Okay. Now you can see we are getting the results in the table. Here we are having the mean for male and female. So these are the mean study hours of female and these are mean study hours of the male. Variance of the study hours for female and male. Total observations are 6 and 5 in female and male. Degrees of freedom are 5 and 4. Now F value is 7.37 and the P value, that is the one-tailed P value, is 0.037 and critical one-tail value is 6.25, right? So what you need to do, firstly you need to convert your P value in the two-tail value, right? So what you need to do, you can come here and you can write P two-tail and come here and do the equal sign, then 2 into and select this value. Fine, and press enter. So this way this would be your two-tail value. Now you need to compare your P value with the 5% level of significance. So you can say this thing that your P value is greater than 0.05. So in that case, you are accepting the null hypothesis of F test. F test means here the F test for the variance, right?
Ma'am, can you show it once again? P two-tail convert.
This value you need to multiply by 2, ma'am.
Okay, okay, ma'am. Okay.
Madam, what is the difference between one tail p value and F critical one tail?
Ma'am, I think you are knowing we can perform test using manual calculations also. So critical means this is the table value and the F value which you are getting here, this F value, this is your calculated value. So
Okay,
this is
ma'am.
calculated value, this is your table value.
Okay, ma'am. Thank you.
Okay. So now you can see we are accepting the null hypothesis here, right? If we are accepting the null hypothesis, we are concluding that the variance is equal in both the groups, right? So where conclusion is variance is equal. If variance is equal, that means you can again go to the data analysis and now you will select the t-test to sample assuming equal variances. Is it clear? May I press OK?
Yes, ma'am.
Yeah. Now you can press OK. And again, it is asking you to give the range. So again, I'm selecting my female variable range. Then I'm selecting the male variable range. Then I am selecting the labels. Hypothesize mean difference. You do not need to pass anything. It is a blank box. So you do not need to pass anything here. Now you can see alpha value is by default 5%. If you want to make any changes, you can do that by using your keyboard. Coming to the output range or output option. So I'm going with the first option and generating the output here. So may I press OK?
Yes, ma'am. Alpha value, why it is required here?
Sorry?
Alpha value.
Alpha means level of significance, ma'am. At what percent of level of significance you want to generate the P value?
That is P value, also called alpha value.
P value, alpha is level of significance, ma'am. P is the probability value. That is different. That will be generated by the software for you. and then you will compare that p-value with the level of significance, that is alpha.
Okay, madam.
Okay. Now you can press OK to generate the output. So we are getting here the output. Now you can see these are the figures we are getting here. So now for male, female, you can see these things we have already seen in case of variance table also. This is the pool variance. You can skip this. We haven't passed any value for hypothesized mean difference. So that is why it is coming as 0. Degrees of freedom is coming as 9. This is the calculated value. If you are want to understand, you can write this. This is calculated figure of T, right? Now this is one tail p-value. This is critical value. That means this is your table value, and this is your two-tail p-value. So suppose we are going with the two-tail test. So we are selecting this p-value. So now we are selecting this p-value. So we can say this p is greater than 0.05, right? This figure is greater than 0.05. So if this is, that means we are accepting the null hypothesis, right? And if we are accepting the null hypothesis, we are saying there is no significant difference in the mean study hours of male and female, right? Is it clear to all?
Yes, ma'am.
Okay. So I hope independent samples t-test is clear to everyone.
Yes,
Shall I
ma'am.
move for the last test now? Fine. Now you can open a sheet with the name paired. Paired samples t-test table is or example is given to you in the 1, 2, 3, 4, 5th number sheet, paired, right? Here you can see we are having weight in pounds before and after. So suppose a particular person is taking any particular diet program, and in that case the company is noting down the person's weight before taking that diet plan. So for example, this is a data of 8 people. So 8 people are going to opt for a particular diet program. So company has noted down the weight of the persons before opting for that diet program, and after a month or 2 months after having the diet program, now you can see these are the weights, right? So now we need to see whether there is a weight reduction after adopting that particular diet program or not. So here firstly I am writing my hypothesis. There is no significant difference in the weight of people before and
बस एक तो सवेर लिए आटा ਨੂੰ ਕਹਦੇ ਨਾ ਗੁੰਨਦੇ ਹੀ ਤੇ ਸਵੇਰ क्या बनाना है हमने
कौर मैम
रोटी है 10 हो
कौर मैम
बना दो
I hope hypothesis is clear to everyone. There is no significant difference in the mean weight of people before and after adopting the diet program. Or I can say this thing, that diet program is ineffective. If there is no difference, that means diet program is ineffective, right? Clear to all?
Yes, ma'am.
Yes. So we have formulated our hypothesis. We are having our data. Now you need to go to the data analysis toolpack, and then you can select the paired samples for means, and you can press OK. Now it is asking you for the range. So you need to give your ranges of the data before I have given, similarly for after I have given. Hypothesized mean difference, you do not need to pass anything. I have selected my data including the labels. I am selecting this checkbox. By default label of significance or alpha value is 0.05. Now output range, where I want to generate my output, so I have selected this particular cell and pressed OK. I have generated the output now. Now you can see here clearly the mean weight before taking the diet program is this. This is the after diet program weight. Variance in the weight is given in the next table, in the next row. Observations were 8 and 8. This is the mandatory condition. Observations in both the cases should be same for paired samples t-test. But when we have applied this independent samples t-test, we have seen these observation number were different, right? But in case of paired, it should not be. If it is, you cannot perform paired samples t-test. Means for both the conduct, you should have same number of people and same number of people. Means same people should be same. Clear? Is it fine?
Yes, ma'am.
Yes, ma'am.
Now, hypothesized mean we haven't passed anything, so it is 0. Degrees of freedom is 7. This is your calculated T. This is your critical T. This is one tail and this is two tail. Now, this is your P value for one tail. This is your P value for two tail. So, if I see this thing, I can say that P is less than 0.05. That means we are going to reject the null hypothesis. And if I am rejecting the null hypothesis, I can say that there is a significant difference in the mean weight before taking the diet program and after taking the diet program. That means your diet program is effective. Why I'm saying the diet program is effective? Because I can say there is a reduction in the mean weight, right?
Yes, ma'am.
Yes, ma'am.
Okay. So I think, friends, this is all from my side for the day. If you are having any queries, now platform is open.
Participants, if you have any question or if you want to share anything related to these topic, please go ahead.
Excuse me, madam.
Yes, sir.
Just now you gave the example of weight reduction. I have also conducted a test on this, before conducting yoga, the blood sugar level, and after yoga. So can I put this t-test paired sample method, madam?
Yes, sir. Obviously, you can put. I think it would be your sample would be same throughout in both the conducts, right?
Yes, that means 20 patients are there with their blood sample reports
Ji.
before yoga and after yoga. The same.
Yes, there's no issues. You can go with that.
Okay, thank you.
Any more questions?
Ma'am, I have one question.
Yes, ma'am.
Ma'am, actually, you said that there is no limitation to the sample size, right? In case of t-test, I have taken a sample of 200.